So we are dealing with problem number 1.84. The problem is stating an aircraft loops the loop of radius 500 meter with a constant velocity v equals 360 km per hour. Find the weight of the flyer of mass 70 kg in the lower, upper and the middle points of the loop. So as we approach this problem, let us first understand what's the loop is like. So this is the circular path in which the aircraft is flying, and I am trying to draw the aircraft to give us a clear picture of the situation. So this is how we can consider the loop situation, where the plane is moving from the lowest point trajectory to the highest point trajectory and then passing the middle somewhere here. Now in the problem, the data that we are given with is that the radius of the loop is equal to 500 meter. It is moving with a velocity 360 km per hour, which we can write it as 360 times 5 by 18, and that will give us a value of 100 meter per second. And the mass of the flyer M is given to us as 70 kg. So over here, if we identify the forces, so we are mentioning this one as point A, this is point B, and this one is point C. So over here, in all the three cases, one thing is clear, that the weight mg is going to be in the downward direction. So the weight at the highest point is in the downward direction mg, at the lowest point is also in the downward direction mg, and over here at point C it is also in the downward direction mg, which we the middle position. Now over here we consider that the force mv square by r is directed outside. So mv square by r is directed away from the center of the circle. mv square by r is directed away from the center of the circle, and again mv square by r is directed away from the center of the circle. And corresponding to the forces, we have normal reaction force. At point B we are writing it as nb, at point A we are writing it as NA, and at point C we are writing it as NC. So these are the 3 points and the 3 values of normal reaction force that we have. So now at the lowest point, we can write that the normal reaction force Na is equal to mg plus mv square by r. So this is the lowest point, and on solving this aspect, we obtain this one as 700 Newton plus m v square, that is 10 square upon r, 500. So over here we have 700 plus 140, 1400, and this one can be written as 2.1 kilonewton. Now at the highest point, which we consider as NB, so at the highest point NB we write it is equal to mv square by r in the downward upper direction, and then mg. So we write it as mv square by r minus mg. So over here, if we put the value which we have already calculated, 1400 minus 700, so we get this value as 0.7 kilonewton. And somewhere in middle, at point C, which we are considering somewhere in the middle, so normal reaction force is solely because of mv square by r. mg is not contributing anything in this situation. So at point C it is only mv square by r contribution. So over here we get the value 1.4 kilonewton. So So these are the three situations which we have solved in this particular problem, that is problem number 1.84.